Now, so in this one, the question says, draw an auxiliary plan of the roofing surface which will show the true shape of the solar panel. Right, before you can even do the solar panel, alright, you've got to find the true shape of it. You've got to find it in elevation, which is simply, alright, the solar panel is right up here. Now, in order to see the true shape of the surface, you need to project perpendicular to that surface. So here's the solar panel here. So 1, 2, 1/2, 3, 4, 3/4. So I'm going to zoom in here and do it. You need to project, so to see the true shape, you need to project from a view in which the surface appears as an edge. So I'm going to draw in my projection lines, okay. So my projection lines are around 90 degrees to the edge view of the solar panel. Okay, and my x1, y1 line, which represents an edge of the vertical plane in an auxiliary plan, alright, it can be drawn anywhere you want, so long as it's perpendicular to projection lines and parallel to the edge of the surface. So we want A, B, C. A, B, C. D, E. D/E. F, G, F/G, H, A/H. Okay. So I'm going to be clever now how I do this. Okay, so E, H, and G have the same distance from the XY line. So I'm going to set my compass to the XY line down to E, lift my compass, mark it in here. Then I'm going to do the same then with what you call it, D, B, C, and F. They all have the same distance from the XY line down in plan. So I'm going to set my compass to that, lift my compass, mark it in here. Now, I'm going to draw in two lines parallel to the X1 and Y1 line. That allows me to quickly select a multitudes of points. I still have some projection lines to carry on. Right, so D is here, B is here, C is there, and F is there. Now we want to get E is here, and we're looking for H is here, and then G is here as well. Alright, now let's get A. So we put our compass on the XY line. Okay, bring it down to A in plan, because this is an auxiliary plan, not an auxiliary elevation. Lift your compass, find A in elevation, follow it along, mark it in there. There's A1. Now we're going to do it with the numbers. So 4, put my compass on the XY line, bring it to 4, lift my compass, find 4 here, follow it along, mark 4 in, 3 is the same. Okay, so I'm going to find 3 here. Sorry, that's 1. Sorry, the earlier point, that's 1. My bad, just the writing is bad there. 1. So I'm going to do the same with 3, or sorry, damn it. I'll have to change that to 3, and then find 1 up here, follow 1 along. There's 1. Okay, so compass on the XY line, bring it to 2, lift the compass, find 2, or find my X1, Y1 line, and mark in 1 there. Or 2 rather, 2. And now I'm going to do the same with 4. So here's 4, there's 2. So 1 joins to 2, 2 joins to 3, and 3 joins to 4. So there's the true shape of the solar panel. Alright, now I have to complete the rest of it. Right, A joins to H. So I'm going to join A to H. Think of yourself as looking this way. A then joins to C. So I'm going to join A to C. Alright, C joins to B. So I'm going to join C to B. And B joins to A1. So I'm going to join B to A1. Alright. C joins to F. Alright. F joins to G. So I'm going to join them together. And then G joins to, G joins to H. So I'm going to heavy that in. E joins to D, so E to D will be hidden detail here. And that's the question complete. So it is. So C joins to A, C to F, F to G, G to H, all done. Right now, let's go to A2. Similar style. Drawn on the right shows the elevation and plan. Draw an auxiliary plan of the lampshade which will show the true shape of surface A. So here's surface A in elevation. So we need to project from a view in which the surface appears as an edge, which is in our elevation. So we're going to execute the same method as we had done there in the past question. So I'm going to draw in my projection lines. And here's my X1, Y1 line. Okay, just bear in mind this line here is from the past question. So 1, 2, 3, 4. Let's just do that. 1/2, 3/4. Okay. Compass on the XY line. Bring it down to 1. Lift the compass. Find 1 elevation. Mark it in there. Alright. Same with 2. Compass on the XY line down to 2. Fine tune the elevation. Follow it along there. Mark it in there. Now 3 and 4. Compass on the XY line. Okay. Down to 3 in plan. Lift the compass, follow it along here, mark it in there. Same with 4 now. So 4, this would be 3, 1, and 2. So we're going to join them together. Right now, okay, we're going to do the front surface, alright? So 5, 6. Now, we're going to be clever about this. Look, here's 5, here's 6. Look, number 6 has the same distance from the XY line as 3. So if you take your compass, draw a line parallel to the X1, Y1 line from 3, where it intersects the projection line from number 6, you'll get number 6. So we can heavy them together, because look, the distance from the xy line down to 6 is the same distance as the xy line down to 3. Alright, same with same over here, alright, with 5, alright, 5 is the same as 4, projection line, find, sorry, that's, I've done 2 5s there, silly me, okay, I'm going to call this, okay, 5, I'm going to change that to an A, okay, I'll do that in a minute. So 4 onwards, 6/5. So follow 5 down here. Here's 5. I'm going to heavy them together. Alright, now those 5 joins to 6. Alright, so 5 to 6 will be hidden detail, because when you look that way, it's blocked by other surfaces, blocked by other lines. That point is blocked by other lines. It's point view of the line 6 to 5. So hidden detail here. Alright, now AB, A/B. So B is the same distance from the XY line down as 2. So line parallel to the X1, Y1 line from 2. And where it hits the projection line coming down from B is B. Now, the same with A. It's the same distance from the XY line as 1 is in plan. So projection line A, and then A joins to B. A joins to number 6. And B joins to number 5. And there's the object done. Right, we'll scroll over to the next question. We've got to pick up the pace here. I'll do A4 while the question is there. Then I'll move on to A3. So the image below shows the atomic structure in Brussels, okay, which is based on an inclined cube. Complete the elevation of the cube. So look, you're given an auxiliary elevation here. How do you know it's projected from the plan? You have a complete plan, you have a complete auxiliary elevation, you're missing the elevation. Remember, if you have a point in plan, its position and elevation is directly above. So first thing, start bringing up all your points from plan. Okay. Right, complete your projection lines in your auxiliary to help you. Okay, so here we go. Here we go there. Right. B. Just B here. Look, 2 points on this projection line, so 2 points here. Or sorry, I'll call that A. A. So A1. B/C. B1/C1. B, C. D, D. E, E. F, G1. So 2 points. The first one is the closest here to you. Imagine if you were looking from there. F would be the closest one. G. H. So D/H. Right, now, easiest way to do it is, look, take the heights from your x1, y1 line and transfer them over to here. So look, take the altitude of the x1, y1 line to point A, lift your compass, find A in plan, follow it on, and mark it in. Alright, so here's A. Okay, same with B and C. Put your compass on the x1 and y1 line, bring it to B1 and C1, lift, find your compass here, mark it in, there's B1, and there's C, C. So B, C. Same with D now. Now there's also another way you could solve it by parallel lines remain parallel in every orthographic view. So compass on the X1, Y1 line brought it to D. Forgot to bring the projection line from D up. So there's D. E now is the same idea. The altitude of E, lift, mark it in there for E. F1 and G1, compass on the XY line. F here, there's F1, or sorry, just F, and this is G, and we're ready to go. Now, our elevation, okay, I'll just wait for the camera to come back up. Our elevation is going to be looking in this way. Alright, how do I know that? Because look where E is in plan. Okay, it's close to my body, my actual body in plan where I'm sitting down. So looking in this way is going to be our elevation. Looking in that way. Alright. E joins to, or sorry, we'll start off with F. F joins to H and H joins to G. Now, G is going to join to E. Alright, so I've joined, and F is going to join to B, so on and so forth. Right, F to B, B to A. H to A. Right now, F is going to join to D. Sorry, F doesn't join to D at all. What am I on about? Sorry, I'm looking at the wrong face. Just one sec there. F is going to join to E. Look, F to E. So F to E here. E to G. Right. D to B. Alright, and I'm not going to see D to B. Okay, because as I look this way, I can't see it. Or sorry, I can see it. B to D. D to E. Okay, now the hidden detail. G is going to join to C. C to A. And D to C. And that is it there. So B, F, D, E, and then G, C, A, H, and that's that one done. Now, same idea. To get the smallest sphere, here's the longest diagonal. It's a true length here because it's a point in this view. Bisect the line. Get half of the true length. That's the radius. Mark it in here. And the height of the center point is up here. This is a true length. The long diagonal here in your elevation is a true length as well, because it appears as a point in plan. And then mark them in. Right, next question. A3. Okay, so the plan and elevation of an end view of archery target is drawn. The line PA represents the plan of an arrow just before it hits the target. The arrow travels horizontally in the straight flight path. So what that means is that in end elevation, it's going to be parallel to the XY line. Okay, and there's the flight path PA. Okay, there it is there. Alright, now so it says draw the arrow PA in the end view and in the elevation. Alright, now sorry, that's A1, we'll say A1, where it hits the board. Draw the arrow PA, in the elevation and plan. So take the, what do I need to do here? I need to bring this line over. Five degrees up. So here's PA in there's its flight, or that's the arrow PA, not its flight path. That's its arrow PA, right? We have to draw the elevation of arrow PA, so straight up. There's P. Okay, we know it travels horizontally in the straight flight path. So, oh sorry, that's not P there. My bad, that's not P. Straight over there from P. That's P there. And here's A. So there's the elevation of arrow PA. Right. Now it says determine the projections of the arrow when it hits the target. When it hits the target. So I got to extend on this line. Okay, I'm going to move A to P with my compass and mark it here. This is when the arrow hits the board. So that's when it hits the board. Alright, so to get that in plan, drop A1 down here, 45 degrees, straight across. So there's A1, P1 then. Just applying the rules of orthographic projection. Here's P1. And then in elevation, straight up, straight across. There's A1. And then I'm not going to get you to do part C, as you're not ready to do that yet. Alright, next one I'm going to do is the geological geometry. Thanks, bye.